We present a novel robotic platform leveraging smartphone technology that was developed at a cognitive anteater robotics laboratory at the University of California, Irvine. The motivation was to create an inexpensive robotic platform using off-the-shelf components and open-source software, which could easily be built by students, hobbyists, or researchers, yet still be able to perform complex tasks. We believe three main components can fulfill these requirements. First, a smartphone running the Android operating system is used as the onboard computer and sensing device for the robot. The computing power, compact battery, sensing capabilities, communication options, and intuitive programming interface of Android phones make them an ideal choice for robotic onboard computers. Second, an electronic device called a yo-yo, which can link the Android phone to peripheral devices such as servos, motors, and sensors. Last, a remote-controlled vehicle available from any hobby store. RC vehicles are robust, come in a variety of forms, and provide a platform that includes batteries, motors, servos, suspensions, and electronic speed controllers. A prototype Android car was constructed using an RC car, an Android phone, a phone holder, and a yo-yo, for a total cost of less than $400. The Android phone sent PWM signals to the RC car for steering and speed control through the yo-yo, which was connected via USB. Using a laptop computer, we communicate over Wi-Fi to an Android application that controlled the vehicle and streamed video and sensory information back to the computer. Next, we built an autonomous robot based on this approach. We built a base using a sheet of perforated steel and mounted it on an RC car. Infrared sensors were then mounted on this base, and the Android phone was mounted on a pan-tilt unit made with servo motors. Panning and tilting was achieved by sending commands from the Android phone to the servos through the yo-yo. In a follow the leader task, which was a part of an Android programming class, students programmed a leader robot that could be controlled remotely with one phone, and an autonomous follower robot that used OpenCV libraries to visually track an object on the leader robot, as well as avoid obstacles. We also used our platform for a research experiment known as reversal learning in cognitive science. In this foraging task, the robot was controlled by a neural network running on the Android phone, which simulated brain areas necessary for this learning. The robot used local sensing and GPS to learn where resources were located and when to search for new resources as they were depleted at a location. The Android-based robotic platform introduced here is flexible, innovative, and affordable. Depending on the choice of phone and RC vehicle, its usage can range from hobbyist to educational to complex research projects.